Let's go down memory lane. It's about 7 million years ago, somewhere in Africa, and our ancestors are living in the trees alongside chimpanzees and gorillas. Everyone's getting around on all fours, swinging through branches, knuckle-walking across the forest floor. Standard primate stuff. But then something absolutely wild happens. Some of our ancestors make a decision that seems, frankly, ridiculous. They decide to stand up, to walk around on just 2 legs instead of 4. And here's the thing, this shouldn't have worked. Walking on 2 legs is slower than 4. It's less stable. It makes you terrible at climbing. By all accounts, it's a downgrade. And yet, here we are. 7 million years later, the only apes on Earth who walk exclusively upright. This decision, this bizarre evolutionary gamble, is literally the reason you're watching this video right now. So today, we're going to unravel one of the greatest mysteries in human evolution. Why did we start walking on 2 legs? Trust me, the answer is way stranger than you think. Let's start with why this is such a puzzle in the first place. Because when you really look at it, bipedalism makes no sense. Think about it from a survival perspective. You're an early ape trying to make it in prehistoric Africa. Predators are everywhere. Big cats, hyenas, crocodiles. Now, what's your best defense? Speed and the ability to climb trees fast, right? Well, guess what? The moment you commit to walking on 2 legs, you become slower on the ground than your 4-legged cousins, and you become worse at climbing trees. You've just made yourself more vulnerable to every predator in your environment. But it gets worse. Bipedalism is metabolically expensive when you're still adapting to it. Your spine, which evolved to be horizontal like a suspension bridge, now has to be vertical like a column. That's why humans have chronic back pain. Our hips had to completely restructure. Our feet, which were designed for grasping branches, had to become flat platforms. Childbirth became dramatically more dangerous because our pelvises narrowed to support upright walking. And here's where it gets interesting. For at least the first million years of bipedalism, our brains didn't get any bigger. So we weren't walking upright because we suddenly got smarter. We were walking upright while still having the brain size of a chimpanzee, taking on all these disadvantages for no obvious cognitive payoff. So why on earth did natural selection favor this? What possible advantage could outweigh all these costs? Well, scientists have proposed over a dozen different theories, and the truth is probably a combination of several of them. Let's dig into the most compelling ones. Theory 1. The changing landscape. The most widely accepted explanation starts with climate. Between about 10 and 5 million years ago, Africa was undergoing a massive environmental transformation. The continent was becoming drier, and those dense, continuous forests where our ancestors lived were fragmenting. They were breaking up into a mosaic of forests, woodlands, and open grasslands called savannas. Now imagine you're an early ape in this changing world. The trees are getting farther apart. There are these open grassland areas you need to cross to get from one patch of forest to another. And here's where bipedalism suddenly makes sense. When you stand upright, you can see over the tall grass. You can spot predators from farther away. You can see where the next group of trees is located. In an environment where visibility equals survival, height is everything. But there's more. When you're walking upright across an open savanna, you also expose less of your body to the scorching midday sun. Think about it. If you're on all fours, your entire back is a solar panel soaking up heat. But if you're upright, only the top of your head and shoulders are exposed. Plus, you're higher off the ground where there's more breeze to cool you down. In the brutal heat of the African savanna, this actually matters. Some studies suggest bipedal walking in open terrain can reduce heat absorption by up to 60% compared to quadrupedal walking. This is the savanna hypothesis, and for decades it was the dominant explanation. But here's the problem. We now know that the earliest bipedal fossils, like Sahelanthropus and Auroran, come from environments that were still pretty heavily wooded. So while the savanna theory is part of the picture, it can't be the whole story. Theory 2. The food hypothesis. So let's talk about another compelling theory. Food. Specifically, what happens when the food you need is no longer within arm's reach. As those forests fragmented, fruit-bearing trees became more scattered. Our ancestors, who loved fruit, suddenly had a problem. They needed to travel longer distances between food sources, and they needed to be able to carry food back to a safe location rather than eating it on the spot. And here's where two legs become a game changer. They free up your hands. Think about the advantage here. If you're walking on all fours, you can maybe carry something in your mouth. If you're bipedal, you can carry armfuls of food, you can carry infants, you can carry tools. Anthropologist Owen Lovejoy proposed that males who could walk upright could carry food back to females and offspring, making them more attractive mates. This is called the provisioning hypothesis. And while it's controversial because it makes a lot of assumptions about early social structures, the basic principle is sound. Freeing the hands is huge. But there's another food-related angle that's even more interesting. Standing upright allows you to reach food that other primates can't access. You can reach higher branches. You can pick fruit from small trees while standing on the ground. Some researchers have observed modern chimpanzees standing upright specifically when harvesting fruit from small trees in open woodland environments, the exact type of habitat our ancestors were adapting to. And there's one more thing. Bipedalism is actually more energy efficient than quadrupedal walking for long-distance travel. Yes, you heard that right. Studies comparing the metabolic cost of walking in humans versus chimpanzees show that once you're fully adapted for it, walking on two legs uses about 75% less energy than chimpanzee knuckle walking over the same distance. In a world where food is scattered and you need to cover more ground each day, this efficiency becomes a real advantage. Theory 3. Thermoregulation and water. Now, here's a theory that doesn't get enough attention but might actually be crucial: water. Or more specifically, the lack of it. As Africa dried out, water sources became scarcer and more spread out. Our ancestors would have needed to travel longer distances between waterholes, often during the heat of the day. And this is where the thermoregulation benefits of bipedalism become not just helpful, but potentially life-saving. Here's the scenario. You're an early hominin, and you need to cross several kilometers of open terrain in the African heat to reach the next water source. If you're quadrupedal, you're low to the ground where temperatures can be 10 to 15 degrees hotter, you're exposing your entire back to the sun, and you're generating heat through exertion. The risk of heat stroke is real. But if you're bipedal, you're not only exposing less body surface to direct sunlight, you're also taking advantage of thermals and breezes that are stronger higher off the ground. And another twist on this is, bipedalism works synergistically with another unique human adaptation. We are the sweatiest primates on the planet. We lost most of our body hair and developed millions of sweat glands. These two adaptations together, upright posture and efficient sweating, create an incredibly effective cooling system that allows us to be active during the hottest parts of the day when most predators are resting. This is huge. This means our ancestors could access resources during the midday heat when there was less competition and less danger. They could travel longer distances without overheating. Some anthropologists argue that these thermoregulatory advantages might have been the primary driver of bipedalism, with everything else being secondary benefits. The social and display theories. But wait, there's more. Some researchers think the answer might be at least partially social. Standing upright makes you look bigger and more intimidating. If you've ever seen a chimpanzee stand up and display during a confrontation, you know how effective this can be. Could early bipedalism have been favored partly because it made individuals more impressive during social displays or territorial disputes? There's also the aquatic ape hypothesis, which suggests our ancestors spent time wading in shallow water and that bipedalism evolved to keep our heads above water. I'll be honest. This theory has very little support among mainstream anthropologists, but I mention it because it shows just how creative researchers have had to be in trying to solve this puzzle. The truth is, we're probably never going to find one single smoking gun explanation for bipedalism. Evolution doesn't work that way. What most likely happened is that bipedalism was favored because it provided multiple small advantages across different contexts. It helped with thermoregulation, it improved efficiency for long-distance travel, it freed the hands for carrying, it provided better visibility in mixed terrain, and it may have even had social benefits. Each of these advantages alone might not have been enough to overcome the costs, but together they created a tipping point where natural selection began favoring individuals who spent more time upright. So here's what we know. Around 7 million years ago, as Africa's climate changed and forests fragmented, Some of our ancestors began spending more time on the ground in mixed woodland and grassland environments. In this new world, standing upright provided just enough advantages in enough different situations that it began to spread through the population. It wasn't a sudden switch. The fossil record shows us a long, gradual transition. Early bipedal species like Ardipithecus still had many ape-like features and probably spent significant time in trees. Over millions of years, as our ancestors committed more fully to life on the ground, their bodies became increasingly specialized for bipedalism. The spine curved into an S shape to better support upright posture. The pelvis shortened and broadened. The legs lengthened. The foot arches developed. Big toes stopped being opposable and became aligned with the other toes for push-off during walking. And here's the beautiful irony. Once bipedalism freed up our hands permanently, everything changed. Free hands meant we could make and carry tools. Tools meant we could access new food sources, including meat. Better nutrition eventually supported larger brains. Larger brains led to better tools, more complex social structures, language, and eventually civilization itself. Walking on two legs was the first domino. Every other uniquely human trait, our big brains, our language, our technology, our ability to dominate every ecosystem on Earth. None of it would have been possible if our ancestors hadn't made that bizarre decision to stand up in the African heat 7 million years ago. So the next time your back hurts or your feet ache, remember, you're feeling the evolutionary trade-offs of the most consequential decision in human history. And it all started because some adventurous apes decided that standing up, despite all its drawbacks, just might give them an edge in a changing world.